start the presentation, and this week we're doing it on condition assessment. So, and that's going to be put on by Ben and myself. What we're going to cover is the probability of failure, what's the difference between inspection and condition, what are the benefits of doing this, developing a condition assessment, how do we, if you don't have a condition assessment, how do you build one so that you can start doing condition assessment, what are some of the initial condition assessment techniques that we can use, typical structural performance and grade, service, and estimating useful life. So that's what we're going to try to cover in the condition. So we're going to start off with the first slide here. Probability of failure is a condition assessment. And so when someone uses probability of failure times the consequences of failure to develop risk, they're looking at condition. So condition is the probability of failure. So you need to know how an asset fails to be able to do a condition assessment. So assets can fail physically. You know, they can break, they can crack, they can corrode. So, you know, there's different ways that they can physically deteriorate. But an asset can also fail when it no longer provides the service that you expect from it. You know, when you're driving down a brand new paved road, it's great, but then now you drive down during the spring, it's not the same level of service that you expect, so you need to bring it back up again. So you have to figure out what is the asset doing and at what level does it no longer provide that service, and what are the conditions that make it no longer provide. It can also fail economically. So what are some of the condition assessments that provide economic failure? Well, you know, if you have a vehicle that gets 4 miles per gallon, you're probably thinking of trying to upgrade because it failed the requirements that you ask of it. If you have a water supply that only gives you water at 15 psi and you can't take a shower, you know, it's not providing the service that you expect. So, you know, it's no longer efficient. Inefficient heating systems are obsolete. Portsmouth now has pumps along their waterfront. They can't get parts for them. They all have to be custom machined. It takes approximately 3 to 4 months to get the equipment machined. So it's not functioning what they need. They can't keep it and provide the level of service that they expect. Now we're going to talk about inspection versus condition. When you bring your vehicle in, and we'll use a vehicle for an example, you can have a vehicle pass inspection. You know, it's got good brakes, tires, the horn works, lights work, and there's no safety issues with rust going through the floorboards or anything like that. But it doesn't mean that it's in good condition. You know, when you go to a used lot to buy a used car, all of them have passed inspection, hopefully. So you're looking at their condition, and you look at, you know, part of its condition assessment is its performance. You take it for a test ride. So you start doing more condition level than inspection level. A lot of times when you read an engineering report, and we'll look at water tank condition assessment, and then you're reading the engineering report, and it's really just an inspection. They did not do a condition assessment. And the difference is a condition assessment is a numeric rating on a deterioration curve to show you where that asset is. And it needs to be repeatable. The reason for that is when you do a condition rating, you get a point on a deterioration curve. Okay? So if you do a condition assessment of your water tank 10 years ago, and then you do another condition assessment of your water tank, and you use the same standards, and you see, okay, we've got 3 points. We know where we are on the deterioration curve. But if you got a point here, and then found a point down here in a very short time period, you know that it's deteriorating very quickly, that it's not meeting what your expectation is, and it's gone past your minimum standard level of service. Roads can occur this way, but if you have, we were looking at 2 road condition assessments that were done for on and off ramps. And we found that one of the ramps deteriorated 5 years quicker than the other one. So they were looking, is there more truck traffic on it, everything else, so they started monitoring what kind of traffic, why is it deteriorating. And it wasn't until they did borings of the road found out that the contractor on that ramp used subsurface material for the road, causing it to deteriorate quicker. So taking those points of your different assets and having a good standard condition assessment allows you to look at its deterioration curve compared to what it should be, and then you can make expectations. They knew with that on-ramp, they knew to replace one of the on-ramps before the other one, so they were able to start looking at some of their capital investments. What's nice is when you have all these standards and you go out and do it, but a lot of times when you're looking at things, and for wastewater, if you're looking at the vertical asset, and you're looking at a pump, or you're looking at an electrical panel, or looking at a lot of different things, you know, how do you develop that standard? You know, so you have to know how it fails. So, you know, I don't know anything about lights along the runway, but you know, how do they fail? You know, wiring. So that's what you do. You start looking and saying, well, here are some that failed. What did they fail? They failed in electrical. So now when you do condition assessment, you say, okay, we're going to look at the electrical and say we're going to look at the connections, we're going to look at any corrosion, we're looking at different things, and that's your standard for that light, because you know, it may not fail outside. It might be all stainless steel, look good, but it fails because of the electrical. So you have to know which one. For pumps, it might be vibrations, so you can measure vibrations. And a lot of times, some equipment vibrate more than others, so you can't just say if it's vibrating at this level, it's failed. So what you have to do is see what the vibrations are over time and see if it's getting worse. You know, usually it doesn't get better. I always tell people don't expect it to improve, but so you're looking at deterioration in standard. So you look at the defect type and then look at the extent. Here, you know, if we look at corrosion and look at surface only, it's not going to fail if just the surface is rusted, but it's an indicator. Okay, so the military looks at rust very critically, and that's probably the highest expense for all military costs is rust. So when they look at rust, if they see it on the surface, they address it because it's an indicator that it's deteriorating, and they want to get to it before there's structural corrosion. So they look at that. You guys go at P.S, and there's 2 water tanks on P.S. Okay, one by the guards that is beautiful. They have their logo on it. It looks beautiful. And then another one at the other end that is like you'd be embarrassed to have it hold your drinking water, and that's on the way to be replaced. Both those were built the same year. So again, by taking these indicators and knowing what the consequences are, long-term consequences. Through the military, that paint is like one of their major weapons for maintaining a lot of their assets. So you look at different things on how things consume or how they break. And okay.
John?
Yeah.
This is one of those things that gets honed over time too, right?
Yes, it does. One of the things that we're doing in Allentown is we're going to do a pilot. We're going to go out, and even though there's standards for manhole condition assessment, they're not going to utilize the standards because they're difficult. They're going to develop their own standards, do 10 manholes, evaluate them, see if they meet what their expectations are, and then they're going to do 100 of them. And so they're going to start pulling in how they're going to do their standards, train everybody, and then use that for collecting their information. And by doing the condition assessment, you can do your repairs and maintenance, which we'll cover in our next training session. Visual inspection. Here we're looking at a water pipe, and this water pipe feeds the nursing home and everything. So we look and say, okay, this condition of this pipe, what is it? One condition can be your level of service, what are you providing? Color is measurable, so if you have color in your water at a certain level, it's not acceptable. So that's a condition, is it the asset providing that service? So you could have color, you could have iron, staining of your sinks, toilets, and everything else. So it's not providing the level of service. Now, this condition assessment is able to be fixed through operation, or does it need to be replaced? Well, through directional flushing, you could actually recover the majority of this pipe size, or through polypigging or something along that line, depending on it. But if this was flushed twice a year, this pipe would probably be a lot cleaner. So it's an operation. The second thing is it's not only when you're looking at condition, that buildup also impacts fire protection, because you can't get the same fire flow through this pipe that you would if it was a brand new pipe and opened up. So a fire hydrant, you typically want to get 1,000 gallons. This pipe would probably only limit you to 500 gallons. And the concern is also during that fire, this material will start going through the pumping equipment and everything else, causing wear and tear on the fire. So you need to know, again, at the very beginning, what is failure, because if you don't know what failure is, you're just looking and saying, well, this is a dirty pipe. So you got to know what that pipe does. It provides fire protection and drinking water quality and everything else. So again, you look at the history, have they been maintaining it, and has there been issues? Now if you look at the pipe here, the thickness of it is full thickness. So you're looking at if there's pitting on that pipe and everything else. So again, if there's been leaks on that pipe, you'd have that type of history. So it's an operational, and you interview the staff to get that information. Okay. Developing the standards. Enforcement. Basically, the standard would be that table. So enforcement, for part of our workshop, we set up several tables for different types of assets. We did fire hydrants, and we said, okay, what are the things that break on the fire hydrant? The threads, the cap, the bonnet, the stem, leakage, the breakaway. So we go through and we write down all the different levels. How do you inspect it? How do you develop that standard? So once they develop that standard, they were able to put that into when they do inspections and flushing, they'll have a condition form which will give you a standard number, and they'll be able to compare it from year to year how those hydrants are doing. So we did the pipe, but one of the things when we talked to all the guys, they put bedding was one of the main reasons for a pipe failure. Well, bedding is not a measurable defect. So we then had to work with how do we make bedding, what do we measure to make a measurable level for the bedding. So the question was, whenever they had a break, we would say, take a sample of the bedding and send it up for sieve analysis. So if they have 24 breaks a year, they'll send out 24 samples for sieve analysis and start seeing what kind of bedding they have under their pipe throughout certain areas of their system. So now they're starting to standardize their data collection. And then you have to train everybody that's out there, because every time you touch a pipe, because it's non-massive that you can see, to do a simple condition assessment, and if you're able to do more detail. So that's where we're saying complete the assessment during routine maintenance. Every time you touch the pipe, every time you go and do oil change on the pump, and you hear the vibrations, do an analysis. Because you cannot have your assessment something special all by itself, because you don't have time to do it. It has to be incorporated in your normal workflow so that people are collecting the data through the normal. And as you're doing the condition assessment, it allows you to do better estimating of life. A lot of times, when we talk about the accountant, we'll say, okay, the pipe life is 80 years. So that means 80 years to replace it. But through the assessment, what you're doing is all the pipes that were 80 years old really don't need to be replaced when they're 80. Some need to be replaced sooner, most of them probably later, through proper condition, looking what maintenance needs to extend its life. These are some of the tools that are used for water and wastewater for doing assessment. Almost every discipline has their own tools for doing analysis, for bridges, for roads, and I'm sure airports have their own way of doing condition assessment. I just like that expression. But you look at repair history, that's part of the condition assessment. And actually in the asset management program, that goes directly into doing the risk analysis. You can use closed TV. Ben's going to cover more of that. Zoom cameras. So there's a lot of different information. They have logi balls that go down water pipes, and it uses sonar to pick up the thickness of the metal pipe, and will pick up pits and everything else along the way, and they take it out. When you do analysis or condition analysis like that, you have to do a risk benefit because it's not cheap. So when you do a risk analysis for doing that, any pipe smaller than 20 inches is not beneficial to do it. But 20 inches and greater, because of the cost of a break, loss of water, possible surrounding damage to other assets, when a pipe that large breaks, it's worth actually having that analysis done. What you have to do is figure out what point do you need to do it in its life to do that analysis moving forward. Speed values are really indicators of condition, and usually it's operational, but it can be that it's just wrong sizing for the pipe for certain areas. And I'm going to turn this over to Ben.
All right, thank you, John. That's right. Well, thank you everyone for coming. I would like to start off by talking about some of the standards that we'll utilize for assessment condition. First one, and the one I'm most familiar with, is the Pipeline Assessment Certification Program, which is the PACP, and its sister program, the MACP. Those are programs that we use to rate sewer systems to evaluate their condition. For highway group and airport group for runways, they may use the pavement condition index, the PCI, and the bridges, the federal efficiency rating index. And then there's also the manual on uniform traffic control devices, and that deals with the reflectivity of signs. We've all seen the signs are kind of blasted by the storms in the winter, and then in the summer at night you can't see them; they don't reflect correctly. Okay, so I'll talk a little bit about the PACP first. We need to be able to see inside the pipe. So the first thing we're going to do with the PACP is put a camera in it. And it could be a zoom camera, so look up the line a little bit, and we can see some, we can see if there's blockage, or we can see the general condition, but we can't really see the defects up close. So we'll actually use a remote controlled vehicle. And we'll go up with the camera, and the camera's actually able to stop and kind of look at the cracks, and it measures the distance and also measures the angle of the defect that we're looking at. And from that, we'll see the cracks and the fractures. You can see we have a break here, it's broken. This is the actual hole, there's a piece missing. I just showed you a few structural issues. I'd like to talk about the operation and maintenance defects. We have an example here that has the roots. Roots will, and you can kind of see it looks like there's some water. There's some water seeping in here. And then on down below here, you have the grease. That's actually an indication that maybe a restaurant upstream has a failing grease trap. And those are operation and maintenance defects because they can be cleaned. They can be repaired without digging things up. I mentioned the infiltration from the roots on the joint. There's also infiltration from the water. It's groundwater that comes in through the breaks as well. Closely related to the infiltration is inflow. And this is an example where John mentioned the smoke testing, where as part of the 9I program, we're looking at the condition. The benefit would be to look at the inflow as well. You can see here, there's smoke coming out. This is a catch basin. It's a large drainage area, all going right there. So we identified a major source of inflow. This is for the town of Air, Massachusetts, where that was all rainwater being treated by the treatment plant. Since then, that's been hooked up to the storm drain. Typically, we'll rate defects on a scale of 1 to 5 in the PAC program, with 5 being the worst case. These are for structural defects, and 1 is the easiest, or in this case, excellent, minor defects. We'll also look at the performance. The performance grades is also 1 to 5. The performance is a little different than the structural defects. It actually, you can actually have a structural defect. You can have a hole in a pipe that has no infiltration and it has a solid vacuum of soil around it. It's constructed right, but the pipe's failing, but the performance, the pipe still conveys everything it was designed to convey. So this one is the pavement condition index. This is something, like I said, the highway group and the airport groups will use. It's addressed in a couple ways we like to look at. This is kind of put in there for a joke, but we talk about the reported complaints. Everyone's running the potholes. They call up, they tell the city, and the cities are starting to capitalize on that. And the city of Manchester is a great example. They actually have an app for your smartphone where you can take a picture of a pothole and it uploads the coordinates. You put in a little information about it. It could be a down stop sign. It could be graffiti. So the complaints is actually becoming a good source of information, and they can address it with work orders and fixing it. But the real message here is the maintenance based on condition assessment. Here's an example of an airport runway and also a road that's had a hard winter. This runway here, it's been crack sealed, so there's been assessment made and repairs made. This one looks like there's going to be a lot of repairs needed. PCI requires a 100-point scale, where in the PACP, 1 to 5, 5 being worse. In this case, 1 to 100, 100 is the worst. And it's a deduct scale. So they'll measure the severity of the cracks and then how often they have the cracks or whatever the feature is that's potholes or broken.
100 is the best.
100 is the best.
Right. You said the worst.
Okay. 100 is the best, so it's a deduct. So each defect is deducted off the top of the 100. Here's a typical form you can see here, where they'll measure the deducts or the defects, and there's the severity up here. So you'll have raveling, flushing, rippling. You'll have the cracks here. You'll have these deducts, or I'm sorry, these distresses rated here, and then the density of distress. That's actually how often it occurs. And then also certain items are more important, so they'll get a weight as well, 3, 1, 1.5, and such. And those will be totaled up and deducted from the 100. Now the bridges uses the federal sufficiency rating program. It's a little bit different in that they break it into sections. They'll rate the superstructure, they'll rate the deck, and they'll rate the foundation. But it is based on a 100-point scale, just like the PCI was. So now what do? We've collected a lot of information. We understand what some of the issues are, so we've got to organize it so we can relate it to our client. In this case, this is part of a capital improvement program where we rated the different sewer lines. This is in Vermont, and we assigned the boxes here talk about what the rating was, what its condition is, and also the recommendation for its repairs. So we're talking about estimating the remaining useful life. We have the current condition, we know that. There's also environmental conditions. The water line, if it's made out of ductile iron, is it in a corrosive environment? Is it going to be pitted early? How long is that going to last? Is it deep enough? Sometimes if it's not deep enough, there may be deflections in the line itself too. So various service. How often is the sewer used? Is it done full? Is there is it backing up in the manholes? So what is that severity service? And past experience. And this one's interesting because if you talk to some of the guys who've worked in these areas for a long time, they'll say, yeah, this part of the town we have a lot of problems with, but this part we don't. And that might be due to a contractor who didn't put enough bedding in, as John spoke at earlier. So the water line may be failing more often in one part of town, but not the other. So we'll look at the past experience for estimating the useful life. We understand what the useful life, how long it's going to last. The next thing we need to look at is the cost. How much is it going to cost the town? The town may have X amount of dollars each year for sewer repair. So then we have to prioritize those repairs. And also, we may have a line that's failing just as much as another one, but this is the main line. This is a little line going up to a cul-de-sac, so we're going to put that one off because we don't have enough money to do both. That's typical in the war. The prioritization of these projects. So we kind of talked a little bit about the inspection and condition. We talked about the benefits and the standards and the useful life. I think if John, you want to join me up here, we'll answer any questions you may have. Yes?
Where's that PCI? Where's that PCI form found? Is that provided by the client? Yeah.
Did you like it?
I know where this is going.
Where's it? Yeah, right. Where is this going? We do have actually several different PCI forms. Some that clients have provided us. This one was not provided by a client. But I can't tell you where the history, where it came from. I have a whole folder of forms for different condition assessments, and that was one of them. So, yeah. So, yeah, I mean, PCI, I know for Goffstown, they have a form that they currently use, and what they want to do now is they're going to computerize it so that the data is collected out in the field. So they will actually set up the matrix so that it will come up with the PCI that matches the historic PCI. So you're comparing, so what you don't want to do is like, oh, we have 10 years of data on this road. All of a sudden we went to a new software program and all the roads got better, you know. And so you want to make sure that you can compare your historic data. So you fine tune it to meet that.
The towns will have their own priorities. You know, I think you were talking about Portsmouth, or you add in what you think is important, kind of make it up as you go, and use it something like that as a starting point.
So how do they, don't you lose a little bit of industry standard then at that point? If people
It's-
start.
That's been one of the things. What we find is if you hire a professional company that comes in, that televises your system and develops your PACP and everything else, then you can compare it with one town versus another. And, but it's a lot of training. People go through 3 years of training. Portsmouth, all of their guys have been trained to develop that standard. But depending on the size of your town, if you look at some of the MACP standards, it's a huge form, 3 pages, and all of a sudden the guy's out there and he says, this manhole looks just like that last one. Pretty soon they don't even see the difference. And so we actually try and get it to the point of that the client will use. And that's the other thing about developing an asset management program. Sometimes you end up not utilizing the standards to collect the data. And and you don't want to make it so it's not going to be collected. So there's a trade-off. I'm working in Portsmouth with a purist that, when asset management is asset management, and this is the way we should be doing it. And when we put the bedding in there, it was like, doesn't fit, these are the formulas. But sometimes you have to develop it so that it develops information to the customer. And it's really so new. Doing it wrong is right,
Doing it wrong is right. Does that mean it's better to do something than nothing?
Yes, it is. It's better to do something than nothing.
And then modify it as you go.
And modify it. You learn. Like Carl had mentioned, it's a process. This whole program is cyclical. You go through and you look at it and say, man, we really needed a little more information in our condition form because we're learning more. So we changed the form. And what most programs allow you to do is add additional condition assessments without impacting your historic data.
Have you ever used outside sources for those areas that you may not be, or you may not be an expert in, so that you can hone-tune?
I'm not an expert in anything. I work with the experts. When I was in Portsmouth, we invited all the water foremen to the workshop. They're the experts. They're developing the form, not me. If it messes up, it's bad. Oh, did I say that? Sorry. No, but that's what you want to do. Disney when they did their heating system, they had all their heating and ventilation guys in a workshop for 2 days developing condition forms. And when they first started, by half day through, they said, oh, you can't do it. By the end of the second day, they had developed forms that they felt comfortable with. Same with the roofs, siding, and they're very detailed. But they are the experts, the people that do the work every day. When we do bridge analysis, I wouldn't do it for them. I would get the bridge guys to develop the form. And they would use standards that they have.
I guess that's what I'm asking, are we utilizing within our own company, other departments, or other expertise outside of the company that maybe areas that can help us develop a model that we can and utilizing obviously the people that are using it.
Right. And that's what it is. The people that know, that's who you go to for development.
Any more questions?
Expected more from airports. Jeez. Well, very good. Well, thank you very much for coming. The next one is not next week, but the following week. And it's basically how maintenance is eccentric around an asset. So it's basically how your maintenance impacts your useful life and everything. Okay.
Thank you.
Thank you.